let f of x be defined by x times the floor of x. We want to prove that f is not continuous. Okay? So in our case now, we know that the floor function is not continuous. So we're going to use this fact to prove that f is not continuous. We can find one point to prove that f is not continuous. So here the domain of this function is R, the set of real numbers. Okay? So if we can find a point where f is not continuous, then f is not continuous on the whole set. Okay? One key idea here is that to show that f is not continuous, we can, in general, we can show that the limit from the right at some point is different from the limit from the left. Okay, and this happens a lot with the floor function. Okay, so we're gonna focus on that. We're gonna choose a proper point, and we show that f is not continuous at that point by taking the limits from the left and from the right. Okay, if we focus on this interval 0, 1. Okay, here we can focus on this point 1 here. Okay, we will see the limit from both the right and the left. Okay, first let's focus on this interval 0, 1. 1 is not included. Okay, on this interval f of x equals x, the floor of x. Here the floor of x is 0. Therefore, on this interval, f of x is just 0. Okay, now if we take the limit of f of x as x goes to 1, but x goes to 1 from the left, we have 0. Okay, so now if we want to take the limit from the right, okay, so the limit from the right, we see here on this interval 1, 2. Okay, here we see that the floor of x is just 1, and in this case f of x is just x, and in our case now we can take the limit from the right. So we can take the limit from the right. So the limit of f of x as x goes to 1 and from the right, so we have 1, which is equal to f of 1. Okay, so here we see that the limit from the left and the limit from the right are different. This means that f is not continuous at 1. In the same manner, we can prove that f is not continuous on all the numbers in z except when a is 0. So it's not continuous on all these numbers a in z. So in this case, it's continuous on a in z star. That means z minus the 0. Okay, so here we have the limit from the left is 0 and the limit from the right at 1 is 1. Therefore, f is not continuous at 1, and we can say that f is not continuous. Okay, and that's what we need. We can find only one point. Okay, thank you very much.